Okay, so you guys wanted to see the power consumption, or what these radios are capable of pulling for power and whatnot. So I've got a Loco M5, a Rocket M2, and a Power Beam M5 right here. And check this out. I'm going to go over to the microscope for a second. Let's see here. Actually, first, sorry. I'm so unorganized. These guys do actually use the exact same voltage regulator chip on all the boards. And there it is, right there. There she is. Okay, so let's take a look at this with the microscope. Alright, so where'd you go? It's hard to get your bearing with this thing. Alright, so let's see what we got here. So, it'd be easier if I do this. There we go. So the number on the power beam is a Z. Bloody hell. This is so counterintuitive. Sorry. Let me just do this. Okay, it is a Z1212AI. And the rocket is a Z1212AI. Or the local. And let's see, the rocket here is a Z1212AI. So yeah, essentially these are all exactly the same voltage regulator chips right here. There they are. Okay, so the next thing is, let's go on the interwebs and look up the specs on it. Okay, got them right here. Let's look up the specs on it, see what its voltage range is. Alright, jump cut. Right there. Okay, so let's see what we got here. Alright, so I've got the, so let's see here. Features, 4.5 volts to 27 volts operating input voltage range. 70 mega ohm internal and FET efficiency up to 95%. Internal soft start, output voltage adjust down to 0.8 volts. 3 amps continuous output currents, cool. Let's see here, PWM, that's awesome. It's using short circuit protection, thermal shutdown, small size. Point of load DC to DC conversion. Let's see here. So there it is, there's your chip right there. So it looks like it says that the maximum voltage is 27 volts. Let's find out what happens if we put a little bit more than 27 volts through it. Yeah. Let's see if it actually goes belly up or not. 27 volts, eh? I'm pretty sure it'll go a little bit higher than that. Okay, so there we go. Now we've got the spec sheet. There it is. Let's see here. Oh, actually, let's read the description just quickly. It's a high efficiency, simple to use 3 amp buck regulator, flexible enough to be optimized for a variety of applications. The AOZ1212 works from 4.5 to 27 volts input voltage range and provides up to 3 amps of continuous output current on each buck regulator output. The output voltage is just down to 0.8 volts. Yeah, cool. Alright, so yeah, let's jump to the part of the video where I start pumping lots of high voltage into it and see what actually comes through, okay? Let's do this. Hold on a sec. Okay. Turning down the power. Yeah, that LED will work at 4 volts. Okay, so here we go. So I'm going to start off at roughly 3 volts here, okay? So now, let me grab a jumper. What do I got for short jumpers? I don't think I've got any short jumpers. So there's a big long one here. Alright, let's do this and I'll just coil it up. Okay, here we go. So, let's put this one in here, like so. And then we're going to start with the Loco, because personally, the Loco I know is a piece of garbage, so who cares if we blow it up. Okay, so we're going to start the Loco off. Actually, I'm going to tilt this a little bit. Sorry guys, I'm still working on lighting. I got to learn this shit, okay? Learning as we go along. I'm still like small channel. Okay, so we're at 3 volts here. Clearly it's not going to work because I guarantee you the circuitry on this thing is at 5 volts. So it requires 5 volts to operate, which means we're going to need to put at least about 8 to 9 volts into this thing to get it working. So, let's start dialing her up and see when she starts to respond. Oh, look at that. 4.3, it tries to come on. 4.6. It will come on at 5 volts. I'll bet you it's not stable, though. The current draw right now is 700 milliamps. Okay. Yeah, that's my ever in heat cat. Okay, let's try it at 8. 8 should be a stable voltage for it. Okay, here we go. So at 8 volts, you can see that the green LED here is constant. And so, yeah, let's say 7.8 on my multimeter. I trust this thing more than I trust my lab power supply, so I'll have to recalibrate that. at some point. Alright, so this is on, and we'll just show you guys that it's on. There we go, you can see that. Light. Okay. I need lots of light, otherwise the image gets really grainy. Okay, so now let's turn it up. Actually, maybe for this part I should turn it down just a little bit so you guys can see the LED a little bit better. It's gonna get grainy, but whatever. So there's your LED. Okay, so here, let's start turning it up until she pops. Okay, we're at 14. I know this thing will work perfectly up until 24 volts. It says 27 is the cutout voltage. And if it'll go higher than, there we go, we're at 29 volts right now. As you can see, it's still working. 29.5, 30. We're at 30 volts. It's drawing 0.2 amps, so that's 200 milliwatts. And look, you can see that it's still running. Okay, let me do a field test here. It's not that hot. See if we can get it higher than 30. 31. 32. 32 is basically the most we can go, because if you watch the equalized voltage on most renewable energy systems, it's usually 15.6 volts multiplied by 2, so that'd be, what's 57.2? No, hold on a second. Where's my calculator? Oh, shit. Calculator, here we go. 15.7 times 2. Yeah, okay, so yeah, roughly 31.4 anyway. 31.4 is the highest you'll see of an equalized voltage on a power supply, like an MPPT or PWM charge controller for a solar array. So this guy is operating at 32.2 volts perfectly with no problems. Alright, just for shits and giggles, because we know this is the same voltage regulator, let's just unplug it, and let's plug it into a power beam. Because really, there should be no difference, right? Okay. Look at that. 32. It's running at 32. Damn it, you can't see anything here. Hold on. There we go. Okay, so that just goes to show you, okay? So we now have verified. These guys will work perfectly on the variable voltage swing of an off-grid power site. If you guys want, I will take apart a higher-end radio, but I'm telling you that Ubiquiti is pretty consistent with the components that they use across the board, and I'm telling you right now, I'm willing to bet that most passive POE 24-volt powered products you find will handle this. They'll probably have a similar chip, if not the same chip, and they will be able to run at these high voltages no problem. Now, you guys want to see things pop, right? So let me move over to my new power supply. Oh, I think it blew its own fuse. Oh well, either way, we weren't able to blow it. Oh, there's one thing I can do. Hold on. Here's a little trick. Let's do it this way. Ha! You guys want to play with fire? Because I do. Alright, let's me grab my, where's my, here they are. So we're going to change this thing up a little bit. This is going to be cool. Okay, so, what we are going to do instead is I am going to take the power output from here and put it into this. Here we go. We were going to take the negative. I'm going to turn the voltage down on the power supply here to 12 volts-ish. We're going to use a 12-volt battery here to compensate for the lack of power supply. Okay, so oh, I need to do this. Let's see here. Yeah, negative will go in here. So here's my negative. Okay, now positive will go on to, let's see here, negative. And then, let's see, where did the other end of my lead go? And then positive will go on here. Oh, there we go. We did it. We blew the safety diode, actually. How many volts are we at, anyway? It's a lot of current. Let's see here. Let me just disconnect this for a second. I still have one more device we can blow up. Okay, so how many volts are we at? We're at 24.5. Okay, yeah, I shouldn't have popped at that point. Let's turn it down a little bit. So we got positive, negative. Everything should be good here. Okay, so let's try this again. Let's try this on this bad boy. Okay, I'm going to turn it right down, actually. Okay, just double checking my polarity and stuff. There we go. Okay, she's on. She's not happy. Oh, there we go, she's booted. Okay, so now, let's turn it up until it pops. Okay, here we go. 19, 20. The one did it 24 for some weird reason. Not sure why. Well, it'll handle 30. I should probably tilt it up so you guys can see this thing go boom. There we go. There's the voltage regulator right there. Okay, so we're at 30 volts. 30. 31. 33. Doesn't like 33. 34. 35. 36. 37. Oh, 37. 37's the magic number. 10 over. Ah, fuck it. Let's crank it right up. Nope. That's it. She's done. Just that easy. Unless, let's see if there's some kind of circuit protection on here. I doubt it. I'll bet you that diode popped. Yeah, that diode probably toast. See, I don't see any visual evidence of it going boom, but whatever. There you go. You actually got to see something go smoky, and you got to see something else pop. That's really cool, eh? You got to see this thing like burn up. All right, so that's pretty cool. All right, is that right there? Yeah, that diode's fucked. Okay. I wanted to see it one more time. The sacrificial lamb. Okay, we're down to 25 volts. Let's see here. Yep, there she is. She's lit up. And let's do it again. Woohoo! Yeah, she goes dead short at about 38-ish volts. That diode kicks in. Gotta love the smell of cyanide. Isn't it nice? It's like a little campfire. I need some marshmallows. Alright, so there you go, folks. I showed you guys what the actual voltages are that these radios can handle, and as you can see, they can fully handle the full swing of a 24-volt charge cycle. So yeah, you now know the chip, you now know what'll happen, you know the cutoff voltages, and you know what voltage that little diode's going to blow up at.